Hey everybody, welcome to activity 4.1. What happens to a ball as it bounces? So go ahead, open up the activity. And once you get the activity open, keep playing the video. So a quick review. Remember, so far in lessons 2, we're in lesson 4, this is 4.1. So lesson 2, we studied kinetic energy, and we found that kinetic energy is dependent on speed and mass, or there are factors that are involved with determining the amount of Ke. And then in lesson 3, we studied gravitational energy, and we found that elevation or height and mass help determine how much GE there is. And then in lesson 3, we also learned about energy conversion diagrams. We drew some of them. So we're going to take it to the next level. We're going to continue to draw energy conversion diagrams today, but we're also going to add a third type of energy, and that's elastic energy. So we're going to explore how an item bounces today, and that's where we're going to make the connection to elastic energy. So my expectations for you is that you can create an energy conversion diagram for a bouncing ball. So remember, elastic energy is the energy stored in elastic material as a result of stretching or compressing. And the amount of EE is regulated or is related to the amount of stretch or rigidity of an object. And think about the stretch, the first one. If you take a rubber band and you pull it back a little bit and stretch it a little bit, it's probably not going to fly too far after you release it. But if you pull it back further and further and further, it will fly further and further and further when you release it because it's got more elastic energy. Rigidity. A good example of this would be, let me think. So have you ever taken a ruler and pulled it back a little bit and let it snap forward? If you've ever gotten hit by a ruler like that, or if you put it on a desk and you release it, it makes a pretty loud noise because it's pretty loud. There's a lot of elastic energy there. Try and do that same thing with a piece of paper. Pull the paper back, release it. Again, it's not going to hurt if you accidentally hit yourself with that paper, or it's not going to make a loud noise on the desk because there's very little elastic energy because paper is not very rigid at all. So today, these are the things to keep in mind as you're doing today's. What happens to the ball, and in this case, each ball, as you look through a falling object, what happens to other balls as they bounce? Was there a change in speed? How can you tell? What happens to the Ke and Ge in each circumstance? Does the ball's total Ke and Ge decrease, increase? Does it remain the same? And assuming there's another type of energy, which there is, we already talked about, it's going to be EE. When is it increasing? When is it decreasing? What are the characteristics of this energy type? So those are the types of things that, keep in mind these questions as you go through the activities, and make sure you can answer all these at the end of activity 4.1. So here were the directions. Using the diagram of a bouncing ball, fill in a pie chart that represents the energy the ball has at different points. Remember to add a key to your pie chart. At each point, consider the following: which energy types are involved, which type is greater and why, and which type is increasing and which is decreasing. So here's the way it's going to work. So the first thing we're going to do is we're going to look at a bouncing ball that goes down and it comes back up. Now, first of all, one of the first things people will say when they look at a diagram like this, they'll say, what the heck's going on? If I release a ball at 1 and it comes down, wouldn't it go straight back up? It would. But we're going to start to explore elastic energy right here at 4.1, 2, 3, 4, and 5. And if these were all on top of each other, we wouldn't necessarily be able to see it that well. We wouldn't be able to draw energy conversion diagrams. So basically, yes, if you dropped one down, it would probably bounce right up here where my cursor is. But we're spreading this out so that way we can draw energy conversion diagrams for each one of these. So for part 1, we're only going to focus on 1, 2, 3, and then over here 5, 6, and 7. We're not going to focus where elastic energy is happening at first. So this first part really is a review. Think about the bouncing ball activity that we did earlier. Think about the pendulum activity that we did earlier. So the bouncing ball, or the drop ball, was in 3.2 and the pendulum was in 3.3. So we've already practiced drawing energy conversion diagrams. So what I would like you to do is pause the video, draw an energy conversion diagram for positions 1, and do that in circle 1, 2, 3, 5, 6, and 7. GE is going to be blue, KE is going to be red. Now, do you have to have yours color-coded? No, just label them like we did the last time. And then don't forget to put a plus or minus. So go ahead, pause the video, and when you do it, I would probably just lightly shade it in, so if you're wrong, it's easy to erase. And when you get these drawn in, go ahead and restart the video. So go ahead and pause now. Did you actually pause it? Go ahead, pause now. All right, so you've had a chance to draw them in, and here's the answer key. How did you do? Now, one of the things some people will say is, oh, well, when we drop this, and this is the heights, and this is the spot where it goes up and then it comes back down. Now, definitely for 7, there would be no KE. If you've ever had a ball, if you throw a ball straight up, or if it bounces up, as it reaches at the very, very top part, it stops as it changes direction and goes back down. And if this was the spot just after the release, I can understand if you had a very thin sliver of KE in here, because as you release it, gravity's pulling it down right away. It's just not going to have a lot of it. And as we get down here, if we look at it and we divide this up, some people would say, well, isn't this halfway? Well, no, it's not. Halfway would actually be right here in between 2 and 3. So there is no 50-50. So I drew this as 2/3, 1/3, roughly, and then 1/3 and 2/3. As the ball goes down, GE is decreasing, KE is increasing. But as the ball goes back up, KE is decreasing the whole time, and GE is increasing because the ball is going higher into the air. And at the very top, it's all GE, and then this would actually repeat itself over and over and over again. All right, so the next thing we're going to do is we're going to take a look at the second part of this lab. So we're going to look at part 2. In part 2, what we're going to do is we're going to take a look at just 4.1, 4.2, 4.3, 4.4, and 4.5. Again, if the ball was dropping straight down, normally it would bounce straight, well, not quite straight up unless you dropped it straight down, but in this circumstance, it would probably come at a little bit of an angle. We just stretch this part out so that way we can see all these different positions. So what I like you to do is go back to the planner and watch the bouncing ball video, the bouncing tennis ball video. And what I would do is manipulate the playing speed, and I'd watch it in super slow-mo. So go ahead and do that. All right. So as you do that, what I did was I took some screenshots of 4.1, 4.2, 4.3, 4.4, and 4.5. Once we get to 4.5, it leaves the ground. So when we look at 4.1, it's just as it hits the surface. Then it's starting to compress, maximum compression or full compression, and then it's starting to come back up. So what I'd like you to do is, again, take a pencil, and I'd like you to lightly shade these in. Now, notice we actually added EE to it, so elastic energy. So with a pencil, lightly shade them in. How much of it would be GE? How much is KE? How much is EE? It doesn't mean all three are always present. Maybe they're not. And then, is it increasing or is it decreasing? So go ahead, take 2-3 minutes, just sketch these in. Talk about it with your team and sketch them in. All right, so you've had a chance to sketch these in. So let's take a look at how you did. So right here, 4.1 is this spot right here. Theoretically, if it's just as it hits the ground, there's no more GE. It's touched the ground. And just as the ball touches the ground, it's not deformed at all. It's not compressed at all. So the ball would actually have no EE yet. Now, when we get to 4.2, again, there's absolutely no GE because it's on the ground. It's in contact with the ground. So there is no elevation. There is no height. But as the ball is being compressed and it's being squatted, and you can see that right here, it's still got a little bit of speed left because the ball is going down. So right here, because it's about halfway in between, it's about half KE and EE. Now the KE is decreasing, the EE is increasing because it's becoming more and more compressed. At maximum compression, and it looks a little bit different because I had to put it up here so I could draw it in and fit it all in this page, the EE is 100%. So it's not going up, it's not going down, it just is 100%. You might say, well, where's the GE? Again, it's in contact with the ground, so there is no GE. Well, where's the KE? Well, think about it. If you throw the ball straight up into the air, at the very, very top, it stops and it starts to come down. Same thing here. As it fully compresses, it stops for a fraction of a second, and then it starts uncompressing, if that makes sense. So once we get to 4.4, it looks similar to this, and they're both half EE and KE, but now the EE is decreasing and KE is increasing. And 4.5, just before it leaves the ground, it's all KE. It's still touching, but there's no more elasticity. It would be 100% KE. It's not increasing, it's not decreasing, it's just 100%. But a fraction of a second later, now all of a sudden there's GE, and GE is going up, and KE will be dropping. And so that's similar to what you drew over here. So how did you do? Did you get these correct? Did you have to change them up a little bit? Now make sure you got the correct answers for the test. So if you need to change yours up a little bit, be sure to do that. Now what I'd like you to do is go ahead and answer these 3 questions. And once you've answered these questions, start playing the video again. So go ahead, pause it now. All right, now that you've had a chance to answer these questions, we're going to go through the questions. So, number 1, summarize what happens to a ball's energy when it bounces. So, this is going to be a little lengthy. And you saw all the different energy conversion diagrams between these right here and between these right here. So, there's a lot going on. So, it's not an easy answer. What sort is an easy answer? It's just really wordy. So the ball's GE is converted to KE as it drops. When it reaches the ground, it has maximum KE, which then starts to convert to EE as the ball is compressed. When it's fully compressed, it has maximum EE, then starts to decompress. And EE is converted to KE until it leaves the ground. And then once it leaves the ground, the KE is being converted to GE. As the ball moves up, GE is increasing, while KE is decreasing until it gets to the highest point, and then this whole thing repeats itself over and over and over until the ball stops bouncing. How'd you do? A little wordy, but if you need to pause the video to copy this down, feel free to do that. Question number 2. What do you still need to learn in order to explain the bounce? Well, first of all, why does the ball not reach the same height after the bounce? So you might have understood most of the stuff, but here's a question I'm going to ask you, and this might be one that you were thinking too. Why does the ball not reach the same height after each bounce? Why does each bounce go up a little bit, or each consecutive bounce? Why does it go up a little bit less, little bit less, little bit less, until it stops bouncing altogether? Now for number 2, make sure you have a question. If you did not put a question or something here, you will not get credit for it. So you can't just leave it blank, and you just can't put IDK. So it says, what do you still need to learn in order to explain the bounce? Make sure you have something there, even if it's this. And then finally, do you feel comfortable using energy conversion diagrams to represent how energy changes from one form to another? Hint, hint, hint. We've got a test coming up, and you are going to have to be able to use them, interpret them, explain them. So the better you can do that, the easier the test will be. So if you don't feel comfortable, be sure you ask questions. I can help you out. I can re-explain things to you, but you want to be able to do this. All right. So you have completed activity 4.1. And make sure you have everything done. Make sure you have good complete sentences, good capitalization, so you get credit for the full activity. Thank you, and as always, make sure you ask questions if you have any. Bye.